Hey guys, so today we will be discussing the derivation for the midpoint line drawing algorithm. So previously we discussed that what is the midpoint line drawing algorithm. Now we will be doing its derivation. So first of all, let us drive it using a diagram. That is, first of all, we will draw the coordinate axis. Then we will draw the line that we have to find out. Then we will find 2 points, right? 2 points, that is xk plus 1 and this is yk plus 1. And similarly over here we will have xk plus 1 and this is yk. And suppose this is the midpoint of the dotted line. Now over here we know that this point will be yk plus 1 and this point will be yk and this point will be xk plus 1. Now guys, let us find out that what value of the point we will take. That is, either we will take xk plus 1, that is this point, or we will be taking xk plus 1 comma yk. That is, these are the two different points that we have to find out, that which one has to be taken and when. So first of all we will write the midpoint of the two possible next points. That is, the two possible points are xk plus 1 comma yk plus 1, and we have another point as xk plus 1 comma yk. So these are the 2 points. So now we will find their midpoint. That is, the midpoint of these 2 points will be, it will be equal to xk plus 1 comma yk plus half. So this is the midpoint of these 2 points. Now the second step is that, let us, if the midpoint, that is m, let us say this is m, lies above the line. Now what do we mean by this? Suppose if this point m lies above the line as it is visible in this figure, suppose m is above the line, then we will take the point xk plus 1 comma yk. That is, if this point is above the line, then we will be considering this point. Okay, so, and if m lies below the line, then we will be considering the point xk plus 1 and yk plus 1. So these are the two things that we have to consider. So now let us find whether the point m will lie on the line, above the line, or below the line. That is, if m lies on the line, then we can take any of the 2 points. Take any point. That is, either we can take this point, that is xk plus 1 and yk, or we can take this point xk plus 1 and yk plus 1 if m lies above the line. So these are the three cases. So now let us write the normal equation or the general equation of a line, that is y is equal to mx plus b, and we know that m is equal to del y by del x. That is, we have written the equation of this line, y is equal to mx plus b. Now we will be substituting the value of m in this equation. On doing so, you will get del x y is equal to del yx plus del x b. Now we can write this as a function. That is, we can write this as a function of x comma y. From there we will get del y del x plus del x into b minus del x y. Now this is a function with respect to x and y. So now for a point x comma y to lie on the line, suppose this is a point x comma y. Let us consider first point. For a point x comma y to be on the line, then we will have the value of x comma y as 0. Suppose this is the equation of the line and we have a point a comma b. A comma, say it is alpha comma beta, and if this alpha comma beta lies on this line, then the value of x comma y will be equal to 0. So that is what we have written here. Now suppose secondly, if we find a point x comma y to be above the line, say a point x comma y is above the line. So in that case, the value of the function x comma y will be less than 0. Now similarly, if a point, say a point x comma y lies below the line, then the value of x fx comma y will be greater than 0. That is, we have considered three cases for this function. If we have a point which lies on the line, then the value of x comma y will be 0. And suppose if we have a point which lies above the line, then fx comma y will be less than 0. And suppose if we have a point which lies below the line, then we will have fx comma y greater than 0. So now we have considered the three cases. Now let us find the decision parameter. So the decision parameter, say d, will be given by d is equal to f of m. That is, in the function of f x comma y, we will put the midpoint points. That we found out earlier. This is our midpoint that we found out from these 2 points. That is, in fx comma y, we will be substituting the midpoint. On doing so, you will get f of xk plus 1 and yk plus half. Now for simplicity, in order to make our calculations easy, let us consider something. That is, we know that we found out f to be, or fx comma y, as del yx minus del xy plus del x into b. That is, we found out fx comma y to be this. Now in order to make our calculations easier, let me change the color. In order to make the calculations easier, let us write this as ax plus by plus c, where a is equal to del y, b is equal to minus del x, and c is equal to del xb. We have solely done this in order to make our calculations easier. Now we have to find the new value of d, that is d new, from the old value of d, that is d old. That is this d old which we will be using, and we have to find d new. So let us write case 1. Now if the point chosen is, the next point that is chosen is, let me write next point chosen is xk plus 1 comma yk. Suppose if we are choosing this point in this line, that is, if we are choosing this point. So this is considered to be case 1. So here the value of d new will be equal to f of xk plus 2 and yk plus half. That is, we have simply substituted the value of xk plus 1 and yk in this function, that is d. That is, on doing so, we will get a into xk plus 2 plus b into yk plus half plus c. Now let us find d old. D old was initially given to us as fx of xk plus 1 into yk plus half, that I told you earlier, which is this point. Now in this point itself we had substituted the values that was chosen, that is xk plus 1 comma yk, and from that we got the value of d new as this. So now we will find d new minus d old. D new minus d old, or this, let us say this is equation 1, this is equation 2. On subtracting, let me write the equation 2 in full form, that is a into xk plus 1 plus b into yk plus half plus c. Say this is our equation 2. So we are simply finding 1 minus 2. So on doing so, we will get as a. That is, on subtracting this and this, we will get the final answer as a. So from here we know that value of d new is equal to a plus d old, and we know that we had substituted the value of a as del y. So we know that d new is equal to del y plus d old, or we can also write it as dk plus 1 is equal to dk plus del y, or we can also write it as pk plus 1 is equal to pk plus del y. All of these three things mean the same. So now let us come to case 2, when we are choosing the point xk plus 1 and yk plus 1. That is, let us see the figure again. That is, earlier we had chosen this point, now we are going to use this point. That is the one above the line. Now here we will find the value of d nu first. That is, d nu will be equal to f of xk plus 2 and yk comma yk plus 3 by 2. Now we have just simply substituted this point into our d value. That is, over here we have substituted the new point, and on doing so you will get the value as yk plus 3 by 2 and xk plus 2. Now on substituting these value into the equation of f, we will get a into xk plus 2 plus b into yk plus 3 by 2 plus c. Now we will find the value of d old. Now d old is simply the same value, that is xk plus 1 and yk plus half. That is the simple midpoint values that we had taken earlier also. That is which we had taken over here. Now on doing so, we will get the final equation as a into xk plus 1 plus b into yk plus half plus c. And now we will find the value of d new minus d old, which will come out to be a plus b. That is, on subtracting this equation and this equation, you will get your answer as a plus b. So now we have the value of d new as d new is equal to d old plus del y minus del x, as the value of a was del y and the value of b is minus del x, that we had found out from here, in order to make our calculations easier. That is, just let me see, there's this point. So keep on writing this along with me on a piece of paper, so that you are able to understand it correctly and easily. And now we have found out the two values, that is d new when for case 2 when we are choosing this point, that is the one above the point. So we had earlier discussed, if the point lies above the line, then the value of d will be taken to be as less than 0. And over here we had taken the point to be below the line, that is over here. Now guys, we will find out the initial decision parameter, that is the value of dk or d naught. Let us say d naught, initial decision parameter. So for that we will write first of all d as f of xk plus 1 comma yk plus 1 by 2. That is simply the midpoint. Now let us substitute xk and yk as x naught plus 1 and yk as y naught plus half. Now we will substitute this in the equation of f, that is ax naught plus 1 plus b naught into b into y naught plus half plus c. Now on further solving this, we will get ax naught plus by naught plus c plus a plus b by 2. So we know that this is the value of fx naught comma y naught plus a plus b by 2. Now in doing so, we know that if a point x naught comma y naught, we had considered that x naught comma y naught lie on a line. So if a point lies on a line, we know that fx comma y, that is the function f, will be equal to 0. That is, the function fx naught comma y naught will be equal to 0 because the point x naught comma y naught lies on the line. This is our assumption. So from here we will get the value of d naught as, this is all d naught, We will get d naught as a plus b by 2. That is, finally we will get d naught as del y minus del x by 2. So this is the value of the initial decision parameter. You can compare it with the formulas that we had written while writing the algorithm. So this is our final answer, and this is the end of our derivation for a midpoint line drawing algorithm. I know it is a very big derivation and it will take you some time in order to understand it correctly. So let me start from the beginning and give you a brief overview that what we had done. So this is the starting. First of all, we had discussed and drawn the equation, that is the coordinate axis, in which we had considered a line and a midpoint was there, and the midpoint was of these 2 points, that is xk plus 1 and yk plus xk plus 1 and yk, that is these 2 points, and from these 2 points we found out the midpoint. Now we discuss three scenarios. Suppose if m lies above the line, then we will take this point, and if m lies below the line, then we will be taking this point. And suppose if m lies on the line, then we can take any point from these two. Now we wrote the general form of an equation of a line, and it came out to be y is equal to mx plus b, in which we substituted the value of m is equal to del y upon del x. Now from that we got the value as del y del x into y is equal to del y x plus del x b, and we took a del x into y on the RHS and we equated it to a function. That is, we considered this equation to be a function of x comma y. Now we consider three scenarios. That is, suppose if we have a point x comma y and it lies on the line, then the value of fx comma y will be 0, and we had used this point in the derivation below. And similarly, the second case is that suppose if we have a point x comma y and it lies above the line, then the value of f will be less than 0, that is, the function will be less than 0. And the third case and the last case was that if a point x comma y lies up below the line, then our function value, that is function of x comma y, fx comma y, will be greater than 0. So and then we wrote the decision parameter d. It was nothing. We just took the function fx comma y and substituted the value of the midpoint that we had found out earlier. And for simplicity, in order to make our calculations easier, we wrote the value of f that we had found out earlier, then substituted del y as a and minus del x by b and del x into b as c. Then we considered case 1. That is, in case 1 we took this point, that is xk plus 1 and yk, that is the point below the line. So on doing that, we found d nu, that is, we simply substituted these values into this equation, that is this equation. Simply substitute the values over here, and on doing so you will get your d nu as this. And we substituted the value of this into the function value that we had simplified, and d nu was same as the older f function, in which we had simply substituted the midpoint values, and then we also substituted them in the function of x, and from there we found d nu minus d old, which will come out to be a when you subtract 1 from 2. Now we simply rearrange them and we got the value of d nu. Now in case 2, we took the point xk plus 1 and yk plus 1, which lies above the line. So from here we found out the d nu, that is, we again substituted these values into the older f function, and on doing so you will get xk plus 2 and yk plus 3 by 2. That is, we have simply substituted these new coordinates in this decision parameter value. Now we will simply write the function fx in its simplified form, and d old was same as the old point as we have discussed earlier, that is, f will be written as a function of m, that is, the midpoint will be used in this x and y, and then we will write the normal equation, that is a, b and c, which was found out to simplify f, and then we simply found out d nu minus d old and rearranged it, and we got the value of d nu. Now we had found out all the two cases. Now we came to the last part, that is, in order to find the initial decision parameter. Now in order to find the initial decision parameter, we took the old value of f, that is fxk plus 1 and yk plus half, that is, we had substituted the value of midpoints, and we simply wrote xk and yk as the points x0 and y0, and we have considered that x naught and y naught lie on a line. Okay, so and now we took these points and substituted in the equation of fx comma y that we had found out earlier. Now in doing so, we will find that this equation can be written as this, and we know that if a point x naught comma y naught lies on a line, then that function will be equal to 0. So we had simply substituted fx naught comma y naught as 0, and we wrote d naught to be a plus b by 2. Then we substituted the values of a as del y and b as minus del x in order to get our initial decision parameter. So guys, this is our final decision, final derivation, and this is the derivation for midpoint line drawing algorithm. It is a big derivation, and it is surely it comes in the exam. It is a very important derivation. And guys, if you are able to understand this video, and if you are able to understand this algorithm, just try to wow in the comment section, and it would be great to know that you were able to understand it. And please do not forget to subscribe the channel in order to encourage me to make such more videos. So guys, this is it for this one. See you in the next one.